So one of the topics that comes up that doesn't really have a nice place to go in the syllabus in level 2 is coordinates. Fortunately, even at level 2, coordinates is not the most difficult topic out of the whole syllabus, and there isn't that much we need to remember, although there are some key points that we do need to take into consideration when we're answering questions. The first thing we're going to look at is this grid here. There are two axes on this grid. These are these black bold lines. We have the x-axis and the y-axis. When we read off coordinates, we always start with the x-axis, or left to right, first, and then the y-axis after, up to down. So as an example, if I mark the point here, what coordinate do you think that will be? Well, I'm going to count across to the x, 1, 2, 3, and 4, and I'm going to go up 1, 2, and 3, and so my answer will be 4 in the x-axis and 3 in the y-axis. And that's how we're going to label our coordinates. We're just going to put them in brackets, and we're going to put 4, 3. In this case, it would be 4, 3. So what would this one down here be? Well, we're going to count across 2, 1, 2, and we're going to count down 3, 1, 2, 3. So you see this is negative. We're going to have 2 and negative 3. Then that would be the answer for that one. For the green one, I'm going to go over here now. These get a little bit more complicated, but not too bad. We're going to go left 5, 1, 2, 3, 4, 5, so it's negative 5, and down 2, so it's negative 5, and negative 2. And then the blue one, finally, we're going to go up here, let's say this one here. We're going to go left 3, so it's negative 3, and up 5, so it's going to be positive 5, so it's negative 3, and positive 5. And that is our coordinate grid. You notice here we have both of them are positive. Here we have the first one positive and the second one negative. Here we have both negative, and here we have the first one negative and the second one positive. And that will always be the case if they end up in one of these four sections. Now, the sort of questions you'll be asked are either to plot some coordinates on a graph or to identify where some coordinate points are. So we'll start with plotting them. So if you very crudely draw a little bit of graph paper with your x and y, and make sure you plot the points and have some practice on plotting these points, and I'll see you in a few seconds when we go through this together, okay? Okay, so firstly, we look at the point 2, 3. We know that x to y means we're going 2 across and then 3 up, so my point is going to be here. I'm going to do this in black first of all. So it's going to be 2 and 3. The second one is minus 4 and 4, so we're going to minus 4, then we're going up to 4. That's that one. Then the third one, we're going minus 6, so all the way across to minus 6, and down 1 to minus 1. And finally, we've got the blue one, which is 1, and then minus 5. And you see, again, I've made sure that each one ends up in each quadrant. That won't always be the case, but I've tried to be fair to you all. And hopefully you got that right. If you didn't get it right, go back. Make sure you understand the rules of x and y axis and which one we go first. The common mistakes you'll make are that some people might have put this here and they might have read the numbers the wrong way around. They might have gone 3 right and 2 up, when this is 2 to the right and 3 up instead. And so, yeah, good job if you got those correct. Let's move on. Here's an example of sort of question you might get. Let's say this is a crudely drawn map of a town, and someone's got to deliver mail to each of these 4 places on their round as a postal worker, and we've got to determine what coordinates each of these 4 places are. And so what we'd do is I'd mark down what I'm talking about first. So let's say the cafe, and I'm going to put my brackets like this, and I'm going to write the coordinates in. So if I go left 3, that's going to be minus 3, and then if I go up 3, that's going to be 3. So it's minus 3 and 3. And now that's the first one. So for the next 3, try that on your own, and I'll go through the answers in a second. Okay, so the park, we're going to go 2 across to the right and up 2. So park is 2, 2. And you see how I'm always writing them in brackets. Make sure you always show your coordinates like this. The bookstore, 1, 2, 3, 4, 5 across and 3 down. So that's going to be the bookstore is 5 and minus 3. I'm going to make sure that's all in one line so you can see it nice and clearly. There we go. Bookstore is 5 and minus 3. And finally, the gym, 2 to the left is minus 2. 5 down is minus 5. So we're going to have Jim is equal to -2 and -5, like that. And so that is where all of our coordinate points are. And good job if you got all those right. If you didn't, again, go back, make sure you're okay with reading the right ones off. Coordinates as a topic, even at level 2, are not the most complicated. It's just remembering the one method and then which one's left and right first and which one's up and down first. And we'll go from there. The slightly harder kinds of questions you'll get are where you've got to generate a shape based on coordinates you've been given. So for this example, they say plot the point to make the shape a square and give the answer as a coordinate. I'm going to go through the first one together and then we're going to practice the next two on your own. So, make the shape a square. What do we know about squares? Well, we know that a square has all sides the same length. So, if I calculate how long these ones are by drawing a line with my pencil and ruler and going up here, how long is this line? Well, I've gone up 1, 2, so that's going to be 2. And we know that if we go down again like this, I've gone down to the right 1, 2, so that's 2 as well. And so all of my other lengths have also got to be 2. So what I'm going to do is I'm going to calculate from here 1, 2. And then if I go from here and it's 2 as well, I'm happy. So 1 and 2. So what point is that? That's going to be the point here. And my point is going to be 4 and 0. So my answer as a coordinate is 4 and nothing. And that would be my answer. You can have points that are on the axis, and that in that case it would be 0. So to make a square, you see I've turned it, sort of turned on its side, but I've got a square that is length of 2 in every direction, and that's going to be 4 and 0. Okay, so here is another example. Plot the point to make the shape a right-angled triangle. So this is about knowledge of shapes as well. Give your answer as a coordinate. I'll give you some seconds to pause the video, have a go. There are many answers to this question, so don't worry if your answer is a little bit different to mine. I'll see you in a second. Okay, so what do we know about a right-angled triangle? Well, if we draw a right-angled triangle, I'll just show you an example of what one looks like. We've got a triangle that looks like this. So we've got 2 straight lines and then a diagonal line that connects them up. So, for example, I could put my point here. And if I connected them up, what I'd get is a line that goes up to there, down to here, and across like this, with this being a right angle. And so there are many, many answers to this problem. For example, in this case, it would be 6 and 4. You could also have 6 and 3, 6 and 5, 6 and 6. Anywhere up and down along this line would be an adequate answer. And anywhere up and down on this line too. So if you decided to put your point, let's just do it in red to show you a different answer. Let's say you put your point here. Okay, if we connect those up with red lines, we should still get a right-angled triangle. It's just a different right-angled triangle. And so our red answer, in this case, we would say that's going to be -5 and 5. That's also a correct answer. That's perfectly fine as well. It could go underneath. It could go underneath here. The only place it can't really go is in the middle up here, because it won't make a right-angled triangle if you do that, unless you're very careful with the way you do your lines. So the easiest way to do it is make sure you just go up or down from one of the other 2 points and then label it correctly. I'll just show you a few more examples just to get the point across. If I put a green dot here, if I put a blue dot here, and I connect those triangles up, we'll see that we still make right-angled triangles all the time. It's just with different measures. See, that's still a right-angled triangle. And the blue one, like this. All of these shapes are right-angled triangles, just in different places. And so our coordinate answers, just to make sure we're thorough, if I put this here, we're going to have -5 and -2. That's perfectly adequate. And another answer we could have as blue, we would say that's going to be 6 and 1. And all of these are acceptable answers. And you could have had a different answer again to any of those. But as long as you can visualize it and draw it and show where the right angle is, in the black example it would be here, then we have a correct answer. So good job if you get any of those right. This is about your knowledge of shapes and how we're going to construct them. And so there's lots of different answers. Basically anywhere up and down this line is fine, and anywhere up and down this line is also fine. as an answer for that. Okay, now final one, a little bit more tricky. This says plot the point to make the shape a parallelogram. Give your answer as a coordinate. So again, 5 seconds. Pause the video, have a go, and I'll see you in a second. Okay, so here we have a parallelogram. I've been kind enough to almost complete the parallelogram for you. If I connect these lines up, what do we know about a parallelogram? Well, really, a parallelogram is just a rectangle that is sort of slightly fallen over to one side. And so we know that we have two pairs of sides the same length. We have a side of length 4 here, and we kind of have a side that's gone 1 to the right and 3 down here. So there are two ways of doing this. I know this length is 4, so if I go a length of 4 to the left from here, 1, 2, 3, 4, and then put a point there, and then connect them up, like this, we've made a parallelogram. And so our answer in this case would be 2 and 2. That should be in black, it doesn't really matter, but I'll just change it. There we go. So our point is going to be 2 and 2. The other way of doing it, if you noticed that this has gone 1 to the right and 3 down, then as long as this goes 1 to the right and 3 down, we'll end up in the same place. It's still 2 to 2. Just as a extension question, what if instead of a parallelogram, I wanted to make this shape a trapezium? What would the answer be now? Where would we put our point? Another few seconds to think about that. Well, what do we know about a trapezium? We know that the trapezium is the shape that looks sort of like an upturned flower pot. That's how I like to visualize it. It's a flower pot that's turned upside down. So how are we going to make a shape that looks like this? Well, now we know that this has gone 1 to the right and 3 down. So to make it a parallelogram, a trapezium, I'm going to go the other way. 1 to the left and 3 down, like this. And we made our shape that looks like an upturned flower pot. And so in this case, our answer would be 0 and 2. So very, very well done if you managed to get that. Trapezium is a more difficult shape to visualize. But what we've got is a point at 0 and 2. And that would be that. And at level 2, these are all the sorts of questions you could be asked about coordinates. Generally, they're 2 or 3 marks, and it's more about being able to read off of them and plot points to understand how to visually represent a shape or figure out where a location is on a map or something like that. Thanks for watching.